Hello friends, welcome to my channel. Thanks for choosing my video. This video is a tutorial on a particular conic section called the parabola. At the end of this lesson, learners should be able to define parabola, identify different parts of the parabola, write equation of a parabola having its vertex at origin, identify the eccentricity of a parabola as 1. Before we continue, if you haven't subscribed yet, please click the subscribe button now so that you will be updated of any of my content whenever it drops. Thank you. In this lesson, we will discuss the following: locus, definition of parabola with illustration, parts of parabola, and the part of parabola that we will be looking at. We'll be looking at the vertex. We will look at axis of symmetry, the focus, directrix, Latus Rectum and its length, and then eccentricity. To start with, let's define locus. A locus is the set of all points that satisfy a particular condition or a set of conditions. A locus is a part or shape formed by points that follow specific rules, e.g., locus of set of points equidistant from a fixed point is a circle. Now, I'm going to use this example to illustrate what locus is. According to the example that is being given here, that locus of set of points equidistant from a fixed point is a circle. Alright, so let's have a fixed point. Let's call this O. And let's make some points such that they are equidistant from this point O. For example, let's draw this. And let's call this P1. That is our first point. And let's draw another one. Let's call it P2. I think this is too long. Let's call it P2. Okay, let's call this P2, such that we know that OP1 is equals to OP2 according to the definition that you want to draw points that are equidistant from this fixed point O. Let's have another point here. Let's try to make them look equal as much as possible. Let's call this P3. Let's call this P4. Let's call this. You can draw many points. You can have many points as much as possible. Now, when we connect these points, now though this is not perfectly is not a perfect circle, but this is just what we are saying, that now drawing this, the locus of these points. All these points, when joined together, what it forms is a circle. That is the locus. So the locus is now called a circle. So whenever you draw a point from a fixed point O, such that those points are equidistant from that point, so P1, P2, P3, P4, P5 are equidistant from this fixed point O, then the what you can trace out, those points, when you join those points together, what you trace out is called the locus, and such locus is called a circle. So this is what locus means, and I've given an example and I've illustrated it. So this is an illustration of what a locus is, an example of a locus of a circle. So locus is just it is a shape formed by points that follow specific rule. Now the rule here is that it is equidistant from this fixed point. That is the rule. So if you follow that rule, you get a circle. You trace out a circle. Those points forms a the locus of those points forms a circle. So this is what locus is. And let's move on to the next thing. We have parabola. Now we want to define parabola, because now we are going to define our parabola based on locus. And now we know what locus is, right? So now we can now define our parabola. Parabola this is the locus of all points equidistant from a fixed point called focus and a fixed line called directrix. Now I will illustrate this so that it can make sense. So now they said a fixed line, right? So let's have a fixed line here, and they said a fixed point. So this is a fixed line called directrix, and let's have a fixed point. So let's have the fixed point here. Let's have the fixed point here. Let's call this point O. So now what is the rule? The rule here is that we want to draw points that are equidistant from a fixed point and a line called the directrix. So we want to draw points. Now let's have this let's have this place to be M1, and let me draw a line like this, right? Up to this point. Now I stop here up to this point, and then from this same point I will draw another line to this place. Now let's call this place the first point, which is P1. All right. Now this implies that from our definition we know that then M1 P1 equals to P1 O. That means MP1 equals to P1O. Don't mind that actually they look not to be equal, but this is just what we are trying to say. We know that by definition, I might not draw it equal, but by definition, we know that M1 P1 equals to P1O. So that is what we are saying, that this point here, this point P1 is equidistant from this point O and from this directrix. So that MP1 equals to P1O. That is what we are doing. So every point we'll be drawing will be like that. All right. Now let's pick another one. Now let's start from this place now. Oh, all right. So let's pick from this place and go this way. So we have another point P2. Let's call this M2, and we have another point P2. We have another point P2. Now again, let's move from this place, and let's move to this place. We have another point that let's call this place M3 now, and let's call this place P3. So at every point we see that M2 P2 equals to P2O, M3 P3 equals to P3O, right? So now let's join all this point. Let's join so now let's join P1, P2 and P3. So let's join them, P1, P2 and P3. So this is how it goes. Now we can see that what we have traced out, this locus that we have traced out, the parts that we have traced out, this is what we call a parabola. Can you see this shape now? It's called parabola. So this is parabola. You can see that from our definition, we have been able to draw a parabola from our definition, that it's this parabola, every point on this parabola is such that it is equal from this fixed point O and this line, this vertical line, directrix. All right. So this is the idea of parabola. If I erase these points now, these lines, everything here, and when I erase them, you can see what we have left. This is the shape we have left, right? This is what we have left. So that is the definition of of a parabola. Now let's move on to the next thing. Now we want to describe parts of parabola now. For easy description of the part of a parabola, we shall consider the figure below, which is a parabola with a variable point P with coordinates xy, and with its vertex as the origin V, which is 0, 0. So now we are considering this image, this figure, this diagram. This is what we'll be considering. So we will consider this parabola, which is which has its center, or its vertex rather. It has its vertex at the origin 0, 0. Can you see? And this BP and PF, this F is the focus, right? This F is the focus, and this point P is a general, is any point on this. So this point P can actually it can be here, point P can be here, so that we have our line drawn from here then to this focus. It can be here, so that you have it drawn to the focus. But we just want to pick a point just to that is general. Let's just represent it generally. So that's why we pick P and name it XY, right? So now let's start. Let's define the points on the parts of the parabola. The first one we have is the vertex. The vertex refers to the maximum or the minimum or maximum points on the parabola. In this case, the vertex V is at the origin. So for this parabola that we have here, the vertex is is at the origin. Rather, the vertex is at the origin, 0,0. So this is the vertex. Let me just highlight it for us so that you can see. This is the vertex. This place is the vertex. All right. Better see. Let me draw it here. So if we have a parabola like this point here is the vertex. All right. Now we can have our vertex shifted from, instead of being at the center, we can have it shifted. For example, if we have our x and y axis like this, now our parabola can be here like this. You can see that it's the vertex now here is not at the origin. This is our vertex now. It's not this is the origin here, but it's not at the origin, so it has shifted. So the vertex can be shifted from the origin. All right. But for this case, we are considering a parabola that its vertex is at the origin. And then next thing we talk about is the axis of symmetry. The axis of symmetry is the line which passes through the vertex of the parabola. It divides the parabola into two mirror image halves. It passes through the vertex and focus. For a parabola that has its vertex V at the origin, 0,0, the line of axis of symmetry is y equals to 0. All right. Now I'm going to show us. It's not easily seen here, but I will try to draw it here. You have this parabola here, and this is what we call the axis of symmetry. The line that cuts it into two equal halves is called the axis of symmetry, right? Now, we have the focus always pass through the axis of symmetry. The axis of symmetry always pass through the focus, or let's say that we can say that the focus is always on the axis of symmetry. Now, if you consider this image, this we have here, this line here is. Let me choose. Let me take another color so that I can see that. Now, this color, this line here, you can see. So the x-axis is acting as the axis of symmetry because this parabola is at the origin. So this x-axis is the one acting as the axis of symmetry, right? Axis of symmetry. All right. So let's erase this. So the axis of symmetry in this case is just our x-axis. So the axis of symmetry is the x-axis. And the axis of symmetry, the focus is always on the axis of symmetry, like this. So this is the axis of symmetry, and the focus is always on it, just like the focus is here. It's on the axis of symmetry in this case. The axis of symmetry here is the x-axis, as I've said earlier. Then let's move on to the focus. The focus is a point located on the axis of symmetry. It has its coordinates. A, 0, where a is less than 0 or a is greater than 0, depending on the case. Now, I don't want to talk about this case of a less than 0 or a greater than 0 for now. We will discuss that later, probably in my next video. But the coordinate is a, 0. So let's go back to the diagram, and so this is the focus. You can see this point F is the focus, right? This is the focus. This is the focus. We have already defined what focus is. So the focus is the fixed point. Is the fixed point, whereby this point, this line FP and BP is equidistant from. So this is the focus, right? And then let's talk about the directrix. The directrix lies on the opposite side of the vertex from the focus. It is perpendicular to the axis of symmetry. Now this line here, in fact, focus and the directrix are the two basic things that we defined at first. So this line here, this line BA or AB, you can call it AB or BA, is the directrix, right? And this directrix is perpendicular to this axis of symmetry here. And this point, this focus, and this this directrix, they are equidistant, right? They are equidistant. So that is the directrix, and let's move on to equation of a parabola. Equation of a parabola. So we will still consider the same diagram to derive the equation of our parabola. So to determine the equation of parabola, so you have to consider this diagram, and we have to consider this line BP and PF, right? So let's consider this line BP first. Let's consider this line BP. Let's write out the coordinate of B and the coordinate of P. So the coordinate of I need to change this. Now the coordinate of B is minus A, comma Y, and the coordinate of P is X, comma Y. So this is X1, this is Y1, this is X2, and this is Y2. Alright? So by distance formula, we know that BP square equals to x2 minus x1 square plus y2 minus y1 squared. Now we substitute this point. Substitute x2. Now these are the points that we're going to substitute. We already know what they are. X2 is x, x1 is minus a, y2 is y, and y1 is y. So we substitute into this. So we have that x minus this minus a raised to power 2 plus y minus y raised to the power of 2, and this equals to x plus a raised to the power of 2 plus 0 raised to the power of 2. So we have that BP raised to power 2 equals to x plus a raised to the power of 2. So we call this, let's call this equation 1. Equation 1. And let's consider this line FP. Now let's consider line FP. This is FP. So let's write out the coordinate of F and P. So I want to change the color of this pen now. Alright. So if you consider this, that is the coordinate of F is a, 0, while the coordinate of P remains x, y. So by distance formula, we know that Fp squared will equals to x2 minus x1 squared plus y2 minus y1 squared. This equals to, now we already know what x1, x2 and every other thing here, we know what it is. So we have that this gives x minus a raised to the power of 2 plus y minus 0 raised to the power of 2. This equals to x minus a raised to the power of 2 plus y raised to the power of 2. Now let's call this equation 2. Alright. Now by definition, we know that BP equals to FP. So this is it by definition. According to the definition, we know that this line BP is equal to this line PF by the definition. So we write that by definition we know that BP equals to FP, and we can take the square of both sides. That means BP, the length of BP equals to this. Alright, so that we equate 1 and 2. So when we equate 1, this is equation 1. You can see this equation 1 here, and this equation 2. We have equation 2, this equation 2. So we are going to equate them now. So we have that x plus a square, x plus a all square equals to x minus a square plus y square. So we have x squared, so let's expand this bracket. We have x squared plus 2ax plus a square equals to x squared minus 2ax plus a square plus y squared. So it's what we have here. This cancels this. They have the same sign across. So, and a square cancels out a square. So we are left with 2ax equals to minus 2ax plus y squared. So we can add 2as to both sides. So when we do this, we have 4ax here equals to, this cancels this, and we are left with y squared here. So this implies that y squared equals to 4ax. Y squared equals to 4ax. So this is equation. This is the equation of a parabola. This is the equation of a parabola at the origin. Like that, at the origin. So this equation y squared equals to 4ax. This equation y squared equals to 4ax is the equation of a parabola that has its vertex as the origin. So please take note of that. This works for any parabola that has its vertex as the origin. So we have been able to derive the equation of a parabola now. So what next do we talk about? So the next thing we want to talk about is the Latus Rectum. The Latus Rectum is a line segment which passes through the point of focus and has its two ends on the parabola. it can be shown that the coordinates of these points are 2a, 2a and a, minus 2a. It can also be shown that the length of the latus rectum is 4a. Let's go back to the diagram and let's view the latus rectum on the according to the diagram. So let's use this. So this line RQ here is the latus rectum, and we are saying that you can show that this coordinate Q we have here, you can show that also for R, that these are the coordinates of this latus rectum. So you can see that it passes through this point, this A, this point as the same as the focus. So it's passed through the this focus. So it passes through. We know that it passes through A and minus A, but the y coordinates, you can determine the y coordinates. We can do that, and we can find the length of this. So going back to that page. All right, so here we are. So I will sketch the. I'm going to sketch it so that we can follow up. So we have it here. Then we have the parabola here. So we have this point R. So this A, comma, let's say y1. We don't know y1, and this Q, which is minus A, comma, y2. Take note that this is negative y and this is positive y. Sorry. So we know that the value of y1 will be positive because it's at the positive is positive here, and we know that y2 will be negative because of what its position here. It is negative. All right. So how do we get the coordinate of this the latus rectum? So what we're going to do now is that look at this that we have here. We can see that both point Q and R, point Q and point R, they are both points on the parabola, and we know that any point on the parabola will satisfy the equation of the parabola. So this point R and this point Q will satisfy the equation of the parabola. So all we need to do is just substitute these points into the equation of parabola. So we have that for the point R. Sorry, we have R A, y1. So we're going to put x equals to A into y square equals to 4ax, which is the equation of a parabola. So we're going to put these 2 points, A and y1. So substituting into this, we have y1 square equals to 4a multiplied by a. So we have that y1 square equals to 4a squared. Then we have 1 squared equals to, now you take the square root of both sides, so this is plus or minus 4a squared, and we have that y1 equals to plus or minus 2a. Now we have two values here. We have 2a and minus 2a. Sorry, I need to write this. And we have minus 2a. So now, because of where this point R is, we know that we expect that y1 will be positive, right? So that means we are going to take the positive value. So we take this. So that means the coordinates of R becomes a, 2a, and for the point Q, which is minus a, y2. So again, we are going to substitute into this equation. So we have that y squared equals to 4ax. So we have that y2 squared equals to 4a divided by a. So we have y2 squared equals to 4a raised to power 2. So we have y2 squared equals to plus or minus the square root of 4a squared. That means y2 equals to plus or minus 2a. Again, we have two answers there. Yeah, we have two answers here, which are plus 2a and minus 2a. Now, because of the position of q, you can see the position of q according to the graph. Let's check it. Now, it is negative, as I've said. So that means we are going to take y2 equals to minus 2a. So we take this y2 equals to minus 2a, and so that the coordinate of q will then be minus a minus 2a. So we have shown that the coordinates of the Latus Rectum, they are r, which is a, 2a, and q, which is minus a, minus 2a. Now you want to show that the length of the Latus Rectum, which is rq, that rq equals to 4a. This is what you want to show now. So by distance formula, we know that rq square equals to x2 minus x1 square plus y2 minus y1 square. Alright, so from this will be y2 this is a not negative. It's a not negative, sorry. So this is y2, x2 y2, and this is x1 y1. Alright, so now let's substitute into this. This equals to, we have a minus a raised to power 2 plus minus 2a raised to the power of 2, and here we have 0 raised to power 2. Let me write this very well. We have 0 raised to power 2 plus minus 4a raised to the power of 2, and this is equals to 16a squared. That is rq squared. That is rq squared equals to 16a squared. Then rq equals to the square root of 16a squared. So we have that rq equals to 4a. So we have been able to show that the length of the Latus Rectum is 4a. So irrespective of where the vertex is, so either the vertex is at the center or the vertex is not at the center, the length of the Latus Rectum remains 4a. So let's look at the next thing we want to talk about. So the next thing we want to talk about is the eccentricity, E. So it is defined as distance from any point on the conic section to the focus over distance from the same point to the directrix. So we recall that let's take a look at this. So from our diagram, we have something like this. Oh, I want to sketch the. So we have something like this in our, from the diagram. So we have a point here, then to the point of the focus. So we have a point M here, a point P here, and this focus. So the eccentricity now is defined as the distance MP to the focus, that is FP over the distance from same points on the directrix, that is this split. So we have PM or MP, whatever. So that means this line FP over this line. All right, and we know that by definition, that FP equals to PM. That's FP equals to PM. Right? FP equals to PM. So this implies that FP over PM, that is FP over PM, equals to 1, since they are equal. So it equals to 1. So that means, this implies that the eccentricity of a parabola is 1. So the eccentricity of a parabola is 1. So that's one of the things you must always remember. So let's go back to our point. Now let's see how far we have covered. So back to this, you can see that we have discussed locus, definition of parabola with illustration. Then part of parabola we have vertex, axis of symmetry, focus, directrix, latus rectum, and its length. Then we have eccentricity. So we have been able to cover everything that we have said that we are going to cover. So we are going to talk about other things in the next video, whereby we are going to look at examples on parabola. We are going to solve questions in the next video, so stay tuned. So if you have not subscribed yet, please click the subscribe button to subscribe to my channel, so that you won't miss any information whenever a video drops, so that you can always get it. So subscribe to my channel, comment, like, and share this video. So see you guys next time. Goodbye.